Hello students, welcome to the first lecture in set theory. So in this video lecture I will be discussing what is the definition of set, how can we represent set and various other examples. So first of all, let me tell you that the credit of set theory goes to the mathematician, that is a George Cantor. So George Cantor is credited for developing this technique of set theory, right? Now let me define what is a set. But before discussing what is a set, let me to discuss few things. If we talk about day-to-day life, and if I say that go and make a collection of objects of a particular kind, so let me to write if we make the collection of objects of a particular kind. So when I say objects of a particular kind, what do I mean? I mean, if I say that go and collect the pack of cards. So when I say that yes, make the collection of pack of cards. So what you will do, you'll go back and collect all the cards, right? If I say go and make the collection of a cricket team, so you'll go and make the collection of a cricket team and so on. So similar collections we come across in mathematics also. For example, if I say the collection of natural number, what do I say? It means 1, 2, 3 and so on. If I say collection of whole numbers, you will say it is sir from 0, 1, 2, 3 and so on. If I say integers, so yes, again, since integers have no starting point, so 0 plus minus 1 plus minus 2 and so on, right? And similar others, the collection of rationals, collection of irrationals and reals or complex, right? So these are certain collections. But one thing which we need to observe in these collection is they are well defined, right? What do I mean by saying well defined? So there is a very important word that these collections, right, they are well defined. So this well defined is very important as far as the definition of sets is concerned, because when we say that this thing is well defined, we mean to say that whether a particular object belongs to the given collection or not, whether a particular objects belong to a collection or not. For example, if I say does 1 by 2 belongs to the collection of natural numbers, you will say no, right? No, this does not belongs to, right? So this does not belongs to. Students, this is a symbol which we use for belongs to, right? This is a symbol which we use for belongs to in maths, and this symbol means does not belongs to, right? Similarly, if I say does 1 by 2 belongs to the collection of whole numbers, you will say no. Fine. So this collection must be well defined. That is, the object of only particular kind must belong to a collection. Fine. So after discussing all these concepts, now let me formally define what is a set, right? So now we are eligible to understand the definition of a set. So what is a set? A set is a collection of well-defined distinct objects. So the two words written in this definition, they are very important. That is well-defined, fine. So well-defined we have understood in the above, right? And what is this? Is distinct objects. For example, if I say the collection of natural numbers, you will not repeat 1 2 times, right? Although one belongs, another one also belongs, but you will never repeat this one 2 times in this collection, right? So what is a set? A set is a collection of well defined distinct objects. Fine with this, right? So well defined is clear, distinct objects is clear. Now in journal we usually, so note, we usually denote sets with capital letter. We usually, okay, so there is nothing standard, but usually we use the capital letters to denote the sets. For example, we will use capital A or capital B or maybe any X Y Z, anything, right? So we use the capitals, right? For example, if I say the collection of natural numbers, so collection of natural numbers, so how do I define this set? Collection of natural numbers, right? So this is generally denoted with capital N, right? Similarly, collection of whole numbers. So collection of whole numbers will be denoted by maybe W, right? And collection of integers, it will be denoted by maybe sometimes with Z or sometimes with I, right? And similarly, collection of rational numbers. Collection of rational numbers are denoted by Q. Collection of real numbers, they are denoted with R. Fine. And the collection of complex number, they are denoted with C, right? So they all are the collection of, well-defined distinct objects, right? And generally, when I have to write the set of or the collection of natural number, that is capital N, so it will be starting with curly braces. It will always start with curly braces, and then you will write the elements 1, 2, 3, and it will go on and on, because natural numbers, they never end. Fine. Similarly, you can write all the sets also. Fine with this? So that is all about the definition of a sets, right? Now when let me take this example only. So that is a collection of all the natural numbers. So what is this 1, 2, 3? They are the objects of this set, right? So they are generally called as the elements. So elements means the objects which constitutes the set. For example, if I talk about natural numbers, what are the objects which constitute this set? So they are 1, 2, 3, and so on. So they can be called as the elements of the set, and sometimes they are also known as the members of the set, right? Or the points of the set. Fine with this. And then we talked about that whether it belongs to or it does not belong to, so we are very much familiar with this, right? Now the sets can be represented in two ways. So next we talk about the representation of a set. So sets can be represented in two ways. So that is a one is the roster form, next is the set builder form. So sets can be represented in two ways, that is a roster form and a set builder form. And in order to make you things clear, let me to take an example, right? So as to make the things clear. For example, if I say make the collection of vowels, right? So all of you know what are the vowels, that is A, E, I, O, U, right? So collection of vowels. So there are two ways to represent this, that is either in roster form or in the set builder form. If you say that I want to denote this R, right? So set of vowels, or maybe with any symbol, let me call it as A also. So what you will say? You will say A will come, E will come, I will come, O will come, and U will come, right? So this is one of the way. So if you put the curly braces, write all the elements, right? Obviously distinguishable, well-defined elements. So this type of notation is known as the roster form. Fine with this? What about then set builder form? Set builder form means that in this case, what you will say, that A is nothing but the collection of elements. So these are the collection of elements. So you will say X such that X is a vowel, right? So you have to write all this thing in this form. So this is the format of a set builder form. So how you will say? So this means here X is any arbitrary, right? But there is a condition on X, that X must be vowel. So you will do the collection of all the vowels. So how do I read this statement? I will read collection of all the X. So let me to write collection of all X, and this column will be called as such that, right? So this will be called as such that. So collection of all the X such that, right? Always you will use this such that with column, right? And the first part will always be the collection of X, and then here you will always, in this section, you will always impose the condition. So what is the condition? That X is a vowel, right? So whenever you have to make the set builder form, so there are basically three steps. So the first step is the collection of all the X. Second will be such that, in all these examples the two parts will be same, and the last part will always change, because in the last part you have to impose the condition which is mentioned in the question. So impose the condition. Fine with this? Now let me to take few examples so as to make you things more clear. So write the following in roster form. So if I say A is a set which is a set of all factors of 24. So that is the question. So you have to write all the factors of 24. So you can make the factors of 24 and you can make a list. So write, and then you will form the set. So 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6, 8, 12, and 24. So they all are the factors of 24, and hence the set is given by this in the roster form, right? Then if I say set of all integers between minus 3 by 2 and 11 by 2. So what is minus 3 by 2 and what is 11 by 2? 11 by 2 means 5.5, right? And what is minus 3 by 2? That is minus 1.5. So what are the integers that are lying in between this interval? So here will be 4, here will be 3, 2, 1, 0, and right, minus 1. So what are the integers that are lying between minus 3 by 2 and 11 by 2? So what is the answer? So if I denote this by capital B, so what will be the answer of capital B? So that will be -1, 0, 1, 2, 3, 4, and 5. Fine with this? So moving on to the third example. Set of all letters of the word. So let me to take the word better. What will be the set in this case? So set is a collection of the well-defined distinct objects. So B will come, right? Then E will come, then T will come. Now you will not repeat T twice. Again, you will not repeat E twice, and the last will be R. Fine with this? So that is how we generally denote the sets in the roster form. Now let me to take some examples of the sets in the set builder form. 1 by 2, 2 by 3, then is 3 by 4, then is 4 by 5, right? Then 5 by 6 and 6 by 7. Fine. So you need to clearly observe. So as I have described above, whenever you have to write the set in the set builder form, it is always of the three parts. So first part is the collection of all the x, then is the such that, and last one is the impose the condition. So again, you will follow the same pattern. So x such that. Now what is the condition on x? So you have to observe the pattern. So can I say that x is nothing but, so see what is x? X is x upon, right, x plus 1, right? And if you choose x to be 1, so this will be 1 upon 1 plus 1, that is 1 by 2. If you choose x to be 2, so this will be 2 upon 2 plus 1, that is 2 by 3, right? Similarly for the other elements, but there is a condition, right? So x can be 1, x can be 2, 3, 4, 5 and 6. So nothing more than that. So that is the condition, right? So now let me to write the condition. So collection of all the x such that, so x can be written as n upon n plus 1, where my n is coming from natural numbers, right? So these are the natural numbers, and n must be greater than 1 and less than or equal to 6. Fine. So all these things are very important. So x must be natural, because if somebody will write here n is coming from reals, so between 1 and 2 there are infinitely many reals. Fine. So you have to mention each and every term very much clearly here, right? So x is nothing but n upon n plus 1, where n is coming from naturals, and there is a restriction on n also. Why? Because we have only these 6 elements, so n must come from 1 to 6. So I hope this example is clear. Now let me to take one more example so as to make you things more clear. So now this is a set, and I have to represent this set in the set builder form, right? Again, as I have described above, so this will be from three parts. So first part will be collection of x, then is such that, and the last part is impose the condition. Now what is the condition of x? Now that is very much important. So you need to observe 1 is 1, right? 1 square. 4 is nothing but 2 square, right? 9 is nothing but 3 square. So can I say x is nothing but my n square, where n is coming from naturals? Fine with this? That is how we denote the sets in the set builder form. Let me to take one more example before we conclude this video lecture. Sometimes they ask in the exam that write the solution. So write the solution set of the equation. So they will be providing you an equation, and then you have to write the solution set for that equation. For example, it is x square plus x minus 2 equals to 0, right? And the solution set they have asked in the roster form, right? So what do you will do? So firstly you have to solve this equation, that is x square plus x minus 2, right? So that is very easy to solve. So this is nothing but x square plus x minus 2 equals to 0. So just factorize this. So this will be 0. So take x common, x plus 2, then minus 1 common, x plus 2, this will be 0, and finally x minus 1 into x plus 2 is 0. Product of two numbers is 0. It means either 1 is 0, right, or the second one is 0. So these things must be clear. So that is, if a into b is 0, this implies either a is 0 or b is 0. So that is the approach which I have used here. So it implies that x can be 1 or x can be minus 2. Fine with this? Just make the collection. So this will be, so let me call it as s. So this will be minus 2 comma 1. Fine with this? So that is how we represent the sets in the roster form or in the set builder form, or what is the definition of sets. So all these things must be clear to you now. In case if you have any difficulty, you can ask your doubts in the comment section. For more such videos, do subscribe to my YouTube channel and do not forget to press the bell icon. I hope you have enjoyed this video session. Thank you.